Hello, Ralph. Welcome to the show.
Hi, Jeremy. Thank you for having me.
You're welcome. It's great to see you. So, the first thing I want to ask you is, how did you get where you are today?
So, I think different to how most people I've seen answer this question, which is I did actually intend to join the insurance industry. I studied economics at university, and there was a couple of modules that covered it. A lot on the consumer side, so measuring expected utility from having some certainty in different scenarios and whether that was worth them taking premiums, and then a lot of customer behavior stuff. So covering naturally elasticity in economics, but also moral hazard and fraud. And I generally like the concept of risk as well, just making decisions based on uncertain outcomes. So insurance can seem to fit quite well. I started out as a graduate on a grad scheme on working on a bike product, which suited me quite well as a keen motorcyclist at the time. The underwriters couldn't believe the premiums I was paying on my bike in terms of how cheap they were. They were quite a risk-averse book, and there's me on a 20-year-old on a super bike paying 130 quid or so. And yeah, I was very keen on spending time on upskilling and becoming the kind of the best pricing analyst that I could be. So I think, like many others, that originally looks like taking the actuarial exams and becoming qualified and studying everything there is on the syllabus. But after sitting and passing the first one, I did find that there wasn't really much I could apply to my job straight away. It was financial mathematics, and I'd covered a lot of that at university as well. But looking through the syllabus, it was a similar sort of story. I was quite keen on staying in insurance pricing. I couldn't see myself moving to other parts of insurance, and I figured that if there was something on the syllabus that I could use, it'd be more efficient to just go and learn that as opposed to
Yeah.
learn lots of other topics and focus on exams rather than just learning what I was actually need to learn and applying it. So that's where my focus went, more to potentially other things that could bring value. So I'd been to a few talks, and machine learning was a topic that came up quite a lot, and generally got the impression that not many people knew what it was or what it could do or too much about it in general. So that's where I figured I'd put some focus. And that became useful at my next role. So I was at my first job for a little over 2 years, and then I joined a non-standard home insurance broker, very small, and they didn't have any analytics or budget for expensive software or anything like that. So that's where building things from scratch, that's where looking into open source programming languages and machine learning actually became quite useful, because straight away I had to build the initial pipelines from the bordereau files, build out the reporting and the analysis, but then go and build all the predictive modeling. Machine learning was a really good use case here because there was lots of models I needed to build. I was more interested in the insight rather than deploying them, and of course, it didn't have the expensive software that I was used to. You can build most machine learning techniques quite easily in open source languages. So yeah, these were a great use case, and decided I'd pick one technique. A lot of machine learning software will build multiple different models using different techniques and pick the best one. And I was keen on learning them more in depth, so I figured I'd pick one and learn that. So I started with GBMs, just where they generally perform the best on tabular data. So yeah, use those, and they worked out quite well. And there was a lot of insight that we could get from those, which helped on the pricing side, especially identifying key drivers on poor performance with the most important plots and things like that.
Yeah.
But also the broker didn't have much capability in terms of what they could do with prices, so built out the rating engine, and again that was with code, and that gave you a lot of flexibility to do whatever you please, really. So I was at that broker for about a year or so, and what I'd built in that time was quite a bit different to what I built at the underwriter previously. So I figured there was quite a lot of value in the things that I'd learned to the wider industry, and that was my kind of step into contracting, where the aim was to bring kind of machine learning and more programming approaches to pricing. So the project was just comparing a GBM to a GLM, which was the one I was had been curious about the whole of the previous year, and sure enough, a couple of hours the GBM is built and it's performing better. But the drawback is that the rating engine there was closed source software, and it didn't really
Right.
support models built with
Yeah.
other vendors. There was a way to implement the models, but it was incorrect and it didn't work. So the next project was something that was actually you could implement, which was building postcode files. So the old methodology was use expensive software, was time intensive. I think it was took analysts about 2 weeks worth of time to build a model, but then when you've got multiple
Okay.
perils, multiple products, that's a lot of time being spent.
Yeah, it is.
And the GBM methodology was fully automated. Again, used free open source programming language, and it ended up outperforming the old method as well. So that was rolled out across all the products, and again, as well as postcode classification, it could be used for motor vehicle classification as well.
Yeah.
So by this point, I'm pretty sold on what I've spent my time learning and doing. It's showing to have a lot of value. So that's where I've committed and gone all into learning about data science in more detail. So I've enrolled in my master's, and I started doing these at the broker anyway, but personal projects, started ramping up those and really trying to learn more about the kind of data science field as a whole, and just trying to see what techniques and things could be brought over to insurance pricing. Going forward a little bit, I've gone part-time on my contracts and spending a lot of time on my master's doing all the shiny data science stuff, so image classification, text analysis, building reinforcement learning models, and again spending a lot of time on the personal projects as well. So almost identified more as a data scientist than a pricing analyst with the amount of time I'm spending on the former. And then I think I can't remember when it was now, I think it was about 3 or 4 years ago, you were talking about generative algorithms before all the hype, before it was so common,
Yeah.
writing text and building images. And I just invested in a kind of data science rig, and I went to install a Python library which had which you could do this with, and the requirements was 12 gigabytes of video RAM,
Yeah.
and my rig had 10, and I wasn't really prepared to go and replace my GPU with a bigger one straight away. And even if I wanted to, I couldn't, because you couldn't get GPUs back then, and I was very lucky to get mine. So that was the introduction to cloud, just where if you needed something beefier, you could just go and rent that compute from one of the providers. So that one was started off with AWS. Yeah, built a lot of cool things with AWS. I think particular favorite service on there is Lambda functions, which are
Yeah.
little serverless instances that you can put a bit of Python code and it'll spin up and run the Python code and then spin down, and you're
Yeah.
charged by the millisecond.
Mm-hmm.
But you can actually do so much with those. If you want to break down big tasks and run them in parallel, you can go and spin up thousands of Lambda functions that will all execute on small parts of your task and finish it super
Yeah.
quick. Ended up, you can build whole Python dashboard web apps in them as well. So hosted a few of those, and again, because they're not running constantly, they're quite cheap, and it's had some going for years and have never really been charged because they haven't hit the thresholds. And so managing all the kind of cloud infrastructure, I've gone down the route of infrastructure as code. So using things like Terraform, and then as a Linux user already, using version control, but using Docker, so you can take the environments on AWS, have a kind of a local version, and build and test locally. And I think anyone listening to the podcast at this point will think, "What's this guy talking about? This has nothing to do with pricing."
No, it totally is
Which,
though, and I remember using SageMaker and being like you, just wow, this is really powerful. I can get all this stuff done without using my own computer with a lot of power, and yeah, and it just wasn't being used by anyone else. There is a I think that's quite a steep learning curve when you first go on the cloud, when you first open up like AWS and it's like loads of names of all these things you
mm,
can do. And I think that's quite daunting for people.
yeah, it is. And then, especially where AWS in particular, you can point and click on the browser, but it's not designed to be used that way. It is designed
Yeah,
to be interacted with a command line interface through code. So that's the way they've intended, and it's a completely different skill set to data
yeah,
analytics. It's people who are familiar running servers. They know the language, and it was harder back then as well because you didn't have ChatGPT. Nowadays, ChatGPT does solve a lot of the problems. You can
yeah,
just get it to set stuff up. But
yeah,
yeah, a big thing that makes all of that easier was this is how I got started with Databricks, because it's a user interface over the top of the cloud compute, and it does make it a lot easier to manage all the infrastructure, and you don't need to worry about getting the right things installed and having the right versions of stuff, because
yeah,
it's all in one on Databricks, and there's everything else you need for kind of data analytics best practice. So I started using that a lot, just where it just made everything much easier. And
yeah. Good Databricks, isn't it? It's very fast. I'd love to know how they get it to be so fast. So processing really big tables at lightning speeds, things that you would normally expect to be waiting quite a while for them to process just seem to be done immediately.
so that yeah, that's all to do with Spark. So it's the same people that built Databricks built Spark, which I'd actually started using Spark on AWS before, and this is how I got into Databricks, because it was Spark I was interested in, just because you can run things quickly. And then the good thing about it is it scales. You run a big job, and so your compute will scale up and run everything in parallel, and then as soon as you've finished, everything scales back down, and then you're not
Yeah.
being charged as much. So,
Mm.
yeah, I think my biggest cluster I've provisioned on there was over a terabyte of RAM that I just needed the one time.
Yeah.
So
Wow.
you can just go and have a terabyte of RAM for a bit, and then you don't need it anymore. You don't need to pay for it anymore.
Yeah. Yeah.
But
It's
that's where
fantastic.
almost my two career tracks converge, which is where last year I got the opportunity to build out a pricing architecture within Databricks, and through doing so, introduce kind of data best practices, which will save a lot of time compared to how practices on the old architecture were set out. There's lots of tasks which will take months of time doing, which will just be zero time under the new architecture, and then
Yeah.
everything's version controlled and just make everything going simpler. But the main bottleneck is implementation with other software. But yeah, that kind of brings me to where I am now, where I spent a lot of time doing something that almost felt completely different to pricing, and it does slowly feel like it's converged now, and the
Yeah.
industry has started to move in that direction now as well. So definitely seeing it a lot more common that roles will be looking for kind of Python skills and
Yeah.
machine learning, and maybe one day you'll see cloud on job adverts, but I've not seen that yet, where
I've
AWS or
not seen
Azure's
it
on it.
yet. Yeah. Do you think pricing teams should be moving on to Databricks?
I think so, because I think the trade-off is ease versus cost, and I think there's so much value that will come from the ease of using a platform like that, where installing Python on a work computer is definitely a pain with all the permissions, and then
Yeah.
admin rights and getting things working properly. And even
Yeah.
if you get everything installed, for some reason it'll be slow because it'll be going through a firewall. So if you're
Yeah.
wanting to use kind of more modern techniques, installing Python on everyone's machine and having the right versions of everything is something that would be quite difficult to do. Whereas Databricks, you're all sharing the same compute, so straight away it's all on the same versions, and you don't really have those issues. So then it depends on what the team builds out. But if they're using it to build out streamlined architectures and they're just using proper data best practices, they'll see huge savings in time and big increase in efficiency. So the costs of the platform should outweigh those. And I
Yeah.
think a good thing about the cloud is that it's scalable. So if you build things sensibly and you don't have big jobs running 24/7 and you do batch processing, a lot of stuff in pricing doesn't really need real time streaming streaming
No, that's
architectures.
true
So
as well.
you can
Yeah.
build things super cheap. I've been using cloud and Databricks for several years now, and other than the instances of terabyte RAM and 3,000 Lambda functions, it's generally been pretty cheap, and usually I'm coming underneath the free tiers.
Yeah.
So yeah, insurance data isn't that big compared to what other users of Databricks will be dealing with as well. So it's certainly possible to stay on the cheaper end. I know of projects in Databricks that will use trillions of data points in a data set, and when scoring models will be doing so on billions of requests daily. So that's the
Yeah.
kind of scales that Databricks is designed to handle. And then we've got insurance data
Yeah.
sets, which you have quote data, which is a few million rows, but then other data sets which are just a couple 100,000, if that. You can definitely build things to be cheaper on there, but yeah, it's just a case of being mindful, because it's certainly possible to have unexpected bills on there if things are.
Yeah. I
Uh,
must admit that if people are running SaaS servers with multiple licenses and an insurer, that's an expensive option in itself.
mm,
And it's still fairly common.
yeah, yeah, and yeah, I think if there's definitely the use case in terms of just making things more efficient, but yeah, the ultimately things cost money, and it's more just working out what has a good return. And yeah, I think legacy ways of doing things, if they're expensive and also not that efficient, then
Yeah.
maybe it's worth evaluating those.
Yeah. And Rav, what would you say is your mission for general insurance pricing?
Yeah, I don't think that the mission's changed a great deal. Essentially, it's to bring more modern approaches and tools and techniques to the industry that quite common in other industries that use data and analytics and data science. But it's changed a little bit in terms of originally it was pretty much just machine learning techniques, but machine learning isn't the kind of main value add from data science, because a lot of pricing teams can already build a pretty good
Yeah.
predictive model. So
Yeah. Mm, mm.
you might use machine learning to build a slightly better model, but it's not gonna
Yeah.
change a huge
Yeah.
amount.
True.
But
Mm,
it has a lot of potential for all the other processes around that in terms of getting the data for building those models and validating the models and deploying them and monitoring them.
yeah.
There's tons of tools and approaches that can make all the rest of that fully automated if you wanted, and just make everything much easier. So that's where the value I see is. But I think a lot of people focus on machine learning, and
Yeah.
if they're not interested in deploying it because they see it as riskier, then the rest gets neglected. And I think
Yeah.
that's the oversight. So the mission is still to bring more modern approaches and techniques, but less of a focus on the machine learning. But still obviously have good understanding and still up to use it
Yeah.
myself. because
I
I prefer it.
imagine. Yeah, I could imagine an extraterrestrial observer being like, finding it rather strange that when there's all this that could be done in infrastructure and data, and the higher level, the strategy and the capability of organizations, people seem to push the modeling side.
If you took all the different skill sets in pricing teams, modeling is probably the strongest when you
It
compare to
is.
other industries.
Yeah.
Um,
It is. There's such a big focus on that area, and actually, in my opinion, the returns on improving that can be quite diminishing. With there's so much uncertainty, and often we're dealing with inadequate. Just like you said, it may be millions of lines of data, but some claims are really rare and things like that. So we've got massive amounts of uncertainty, and modelling is not really going to help us with that.
hmm, yeah. So yeah, in summary, so yeah, that's the mission really, just to try and bring better ways of working with data to the industry, and mostly from data science fields, but also data engineering and software engineering if it's applicable.
And what would you say is your vision? Where do you think we should be ending up?
So very similar to to the previous answer, but just working with data best practices that are common in data science. Data science teams operate very differently to pricing teams,
Yeah,
but at the core, they're doing the same thing. They're taking data and using that to build models or analysis to either facilitate business decisions, or that is the actual product if it's a data science product. But they will work in ways which are more akin to software engineering, and
yeah,
it's a lot more efficient and essentially working on a code base and building a system. Whereas I think pricing teams is generally a lot of sporadic ad hoc analysis and processes
yeah,
and tasks. So I think the my vision would be that you adopt more of those principles and build
yeah,
a whole kind of pricing architecture or system that serves all of these, and you work as a code base on improving the system rather than spending time on processes and ad hoc analysis. And I
yeah,
think the what that enables then is freeing up time and focus for pricing specialists rather than focusing on more mundane repetitive tasks and
yeah,
processes and refreshing reports and so on. They can actually focus on pricing challenges, and then that enables more focus on those, and so you have more innovation and people actually working on the harder stuff and utilizing more of their expertise.
yeah. I think it's a really interesting point because prices are actually software. That's really what we're making. And that kind of isn't always realized. I think the where we've come from means there's often a very scientific, kind of academic, researchy backbone to pricing teams. And the reality today is that they're operational teams and they are deploying software into already complicated IT systems to generate people's prices. And that's what the teams are about. Most conversations on, oh, what should we analyze today? It's when are we deploying XYZ? Here's the deployment plan. We need to line up with these sprints and all of this. It's very operational role now.
Hmm. But but then at the same time, a lot of the skill sets which are key in software teams just are don't exist in pricing teams.
No, they don't. It's
Uh,
true.
And I think obviously the main one is programming skills. So there's the reliance on software, which then doesn't, a lot of the time doesn't have the capabilities to do things in the best way as well. Software which doesn't interact with other software,
Yeah.
doesn't allow for automation, doesn't have version control,
Mm.
then suddenly you don't have three of the three key points of building software, which is maintenance and implementation with other parts, version control and automations. Yeah, there's definitely there's that software element of pricing, but then without a lot of the tools and approaches and techniques that you'd see elsewhere.
Yeah, absolutely. Absolutely. It's a fascinating area. I think it's somewhere that's really changing. And I think people are waking up to the fact that there are better software options out there, and they really need to be doing them. They shouldn't be having people work on very manual, old school, old style software solutions when there are such better options available. And as we talked about the cloud as well, it makes a big difference. Thank you very much, Ralph. It's been excellent talking this afternoon, and thanks so much for taking the time.
Cool. Thank you very much for having me.
Cool,
Cheers.
brilliant. You have a good rest of your day. Thanks.
See you too. Bye.
Bye bye.